looking at an angle, it's in radians. First thing I want to know is, divide this. This is what your formula says. I want to get rid of the pi, so I put it on the bottom. And I cross that out. And so what essentially do? I divide 4 into 180. So without your formula, divide 4 into 180. What's your reference angle? 45. So I have a 45-degree angle. So as soon as I do that, I write to myself 45 degrees. Whatever triangle you remember. The easiest one is, because both of the legs are the same, 1, 1. And they add up to 2. One of those has to get a radical. The 30, 60, 90 has one radical. The 45, 45 has one radical. It doesn't make sense for me to do radical 1, because isn't radical 1, 1? So, radical 2. That's your special right triangle. That's all you have to remember. Now, 1 pi over 4 means I'm in the first quadrant. As I open my circle, I opened 45 degrees right here. So I'm going to put this triangle onto my XY axis. This is a circle that came all the way around. And I'm superimposed on my XY axis, which the XY axis is going to help us get the positives and negatives. So I know my triangle, 1, 1, radical 2. Here's the best part. X equals, Y equals, R equals. So X is right along my x-axis. What's that value? No. X, come along the x-axis. What's my x-axis value? 1. Y is parallel to my y here. What's that value? My radius is here. What's that? Radical 2. My radius is the guy that opens. This is also called my terminal side. When your angles open, they start here, they go around the circle like this. Where they stop is your terminal side. Then we drop a triangle. Remember, I have to wear a bow tie. Our triangles only drop down to that x-axis. That terminal side becomes my radius, my hypotenuse of my triangle, right? Now, once you do this, you never have to look back at this graph. You do have to know the sine is y over r. The tangent, let me put cosine. Cosine is x over r, and tangent is y over x. That you do have to know. An easy way to remember that is sine and cosine. Which letter comes first in the alphabet? C. Which letter comes first in the alphabet, X or Y? X. So the X is your cosine. The Y is your sine. If anything, just make sure you know these guys. So now, I say the sine of pi over 4 is y over r. I come here, I say 1 over radical 2. The nice part, no rationalizing. My cosine of pi over 4 is x over r. I just take it right off of I call this my information box. Once you establish that, that's where your positives and negatives come from. You don't have to go back and check where was the all students take chemistry. You don't have to go back and check any of that. My tangent is y over x. My y, 1 over 1. And make it say 1. Now, your reciprocals are nice. They have opposite letters. They don't have the same letter. So sine has a cosecant letter. Just take this guy and reciprocate it. Radical 2 over 1, radical 2. Cosine is a secant. Take this guy and flip it over. Radical 2 over 1, radical 2. And my tangent, my cotangent is x over y, and I don't even care because I'm going to take 1 over 1 and turn it over, and it's still going to be 1. Okay? Now, I'm still not sure if all this is right, so I'm going to take my handy calculator. I'm going to let my mode say radians, and I'm going to say, tell me what the sine of pi over 4 is. And it comes out and it says 0.707 blah blah blah. I'm like, well, I wonder if that's the same as my 1 divided by radical 2. Oh, yeah it is. So I know I'm right. I can use your calculator to verify this. You can't use your calculator to find it because we need exact values. Your calculator can never go back to a radical. It can go back and forth to a fraction and a decimal, but not to a radical. So whenever we say find the exact values, chances are they're your special triangles or your quadrangles, and we can't use your calculator. We can verify them on your calculator. All right. So let's talk this guy. What's the same about this? What's the same between these two? What do you notice that's the same? They're over 4. So how many times does 4 go into 180? 45. So right away, again, I have a 45-degree triangle. 1, 1, radical 2. Now the problem is, where do I start this? So, if you want to, you can take this, you can convert it using your 180 over pi, get rid of the pi, convert the whole thing, or you can use, this way is even easier. This is 0, this is pi, this is 2 pi. I need to make this out of 4. So I need to make this say the same number on top. Doesn't that cancel out to be pi? Right? Isn't that what's going to happen? I don't even have to think about it. Whatever my bottom is, my numerator has to be the same thing. It has to cancel out to pi. This says, oh, you have to double that. So 8 pi over 4. That's good. Thanks, hon. Enjoy your birthday. Okay, now, I kind of know where I'm going. This negative is a little different. What does the negative mean? Well, it tells me instead of rotating counterclockwise, which way am I going to rotate? Clockwise. So I'm going this way, the opposite way. Remember what a negative does? It takes the opposite. So instead of opening up that way, I'm opening down. So, but I'm still going to follow the same routine. There's my 4. I come all the way around. There's my 4. I stop before the 8 because I want 7 pi over 4. It's going to be 1 before that. It's going to be right here in quadrant 1. I'm 1 before that. Look what a 45-degree angle does, guys. Watch up here for a second. This is 0. This is pi over 4. Isn't each quadrant cut by 45 degrees, right? They're 90, so isn't it 245, right? So here's my pattern. This is 2 pi over 4. This is 3 pi over 4. This is 4 pi over 4. 5 pi over 4. 6 pi over 4. 7 pi over 4. 8 pi over 4. Isn't pi over 4 the same, 2 pi over 4 the same as pi over 2? Isn't that your 90? Doesn't this star reduce down to 3 pi over 2? Isn't that your 270? It's just a cycle all the way through. I'm just working with my denominator, adding each of these angles. Every 45 degrees, 45, 90, add another 45, 135, add another 45, 180, add another 45, 225. I could do it in degrees, or I can do it in radians. So this brings me to this triangle right here. But I already know this is 1, 1, radical 2. Isn't that the same exact triangle that I had before? So won't all those values be exactly the same? They're all exactly the same. Make an information box. X is 1, Y is 1, R is radical 2. It's the same angle that was in that one. Pi over 4, positive pi over 4 was the same as negative 7 pi over 4. Today, if we get to today's lesson, we're going to see that those are called coterminal angles. One goes up, the other one comes from the other side and meets it at the same terminal side. So they're coterminal angles. Does it make sense? If I convert this one, let's convert this. I'm going to cross out my pi's. 4 is going to go into 180 35 times. I'm going to multiply that by 7. 45 times. I'm going to multiply that by 7, and I should get 315. So, shouldn't I be all the way over here if I went negative 315? I should be all the way over here, 45 degrees short of the 360, right? Does it make sense in degrees as well? Andrew, are you okay with this?
Yeah.
So, if I'm confusing you, tell me.
Okay.
I know I'm throwing a lot at you, but I want you to get used to rotating it around the circle, finding the special triangles, applying those triangles. From there, all we need to do is this, and then we just need to find your 3 basic functions, and then we can flip them over. All right, let's try another one. I think as you get a little bit more comfortable with trying these guys, I think they're going to be a little bit easier. Now, 3 goes into 180 how many times? 60? 3 goes into 180. 60. So, I've got an angle that says 60. So I best remember that as opposite the 30 is 1. Opposite my right angle is 2. This guy is radical 3. Okay, I'm going to be using this triangle. So I need to figure out where in the world is 2 pi over 3. So I'm going to do the same thing. Instead of pi, I'm going to make it 3 pi over 3. Doesn't that reduce to pi? Why did I pick 3 pi over 3? Because my denominator is 3. Good. And so if I double that, what will it be? Double 3. 6 pi over 3. Doesn't that reduce down to 2 pi? Isn't 2 pi the same as 360? Okay. Now, here would be my 1 pi over 3. Over here. Here. Just short of the 3 should be my 2 pi. Shouldn't it? As I come around your circle, this was my 1. I'm 60 degrees. So just bear with me for a second. This was my 1. This is my 2. I went 180 degrees. Look how many degrees I just went. 60, 60, and oh, there's another 30, 30, there's another 60. So didn't I do 1, 2, 3, all the way around? Now, this is called my reference angle, right here. All I got to do now is put this information on here. Opposite the 60 was radical 3. Opposite the 30 is 1. And my hypotenuse is a 2. I always put the positive numbers on my triangle. And then I worry about the negatives right here. So x in this quadrant is positive or negative? Negative. Y in this quadrant is positive or negative? And my radius is always positive because my radius measures a distance from the center to the circle. So now all I need to do is use this and find my pieces. Sine of my angle is y over r. Come right to your information box. Radical 3 over 2. Cosine is x over r. X is negative 1. Negative 1 over 2. Tangent is y over x. Radical 3 over negative 1 gives me a negative radical 3. Doesn't matter where you put your negative, as long as you just have one negative. Now, I never went back here again. I don't have to check all students take chemistry because this right here said your x was negative in quadrant 2. So anything you do with an x has to have a negative value. Anything you do with the y, your y was positive, had to have a positive value. The only one that gets a little tricky is tangent, because I have to divide a negative divided by a positive. And in quadrant 3, I have to divide a negative divided by a negative. So does this make a little bit more sense? Okay. And again, your cosecant, flip this over. Cosecant, and the nice part is, look, we don't have to rationalize. Secant, flip this over, -2. Cotangent, flip this guy over, -1 over radical 3. I never go back to my triangle again once I pull out my x, y, and r. And I can always check it on a calculator. I can even convert the 2 pi over 3 and find out that's 120 degrees. 120 degrees puts me in quadrant 2 with the 60 degrees before I reach 180, right? So isn't that where this came from? I'm trying to get you to do this without having to convert it all the time. I'm trying to get you to get the flow of this. So, what's different, or what's the same between here and here? I'm dividing by 3. So what special triangle am I going to use?
63.
Again, good. I'm going to use the 60 because 6 goes into 180. 3 goes into 180 60 times. So I'm going to again use my same triangle. But it's going to fall in a different quadrant. So let me label. I'm divided by 3. So what should I label pi in terms of thirds? Same number, top and bottom. Because you want this to cancel out the pi, right? So same number, top and bottom. And what do I do over here? 6 pi. I want to double it. Now, what does this negative cause me to do? Go clockwise. Go the opposite way. So I'm going clockwise now. It sounds like it would be different, doesn't it? It sounds like clockwise would be our positive and counter would be our other. But our angles rotate this way. Because there's your quadrant 1. There's your quadrant 2. This is how your angles open. They open from a standard x positive. And they open counterclockwise. So the negative goes this way. So watch. I want the 5. Doesn't the 5 come right before the 6? So as I go all the way around, I pass the 3, I pass the 4, there's the 5. I drop a triangle. I know this is 60, because 3 goes into 180 60 times. And now I know my triangle. Radical 3, 2, and 1. So x is positive. They're all positive here. Now,
How did you do 3, 2, 1?
3, because my special right triangle is
Oh, it's
opposite, same triangle. Now, watch the beauty of this. All these values, numerical, will be the same thing. The only thing that will change is my positive and negative. And in quadrant 1, do I have a negative in quadrant 1? No. So watch how easy this is. So the sign of negative 5 pi over 3 is, I got it already, radical 3 over 2. Because this was also a 60-degree reference angle, wasn't it? All my 60-degree angles have to work the same. My cosine is positive 1/2. It's 1/2, but I'm in quadrant 1. My tangent is radical 3. Just positive radical 3. The values of them have to be the exact same.
I still get the, when you're finding the going one up, one back.
Okay, so if I converted this to degrees, you would say this goes in here 60 times. That's where you get your special triangle from. Then you do 60 times 5, and you would get negative 300 degrees. So here's 0, here's 180, here's 360. So how did you know what quadrant to stop in? It's negative, and it's negative 300. So how did you know where to place that?
Or 380.
So you went past 180.
Yeah.
You came all the way around, but you didn't hit 360 yet because you're negative 300. So you had 60 to go, right? So it put us in quadrant 1. We do the same exact thing in radians, but we do it a little bit quicker. So we said, take the denominator, 3, and give me the same number up top because I want this to cancel out to pi. Isn't that 180 pi? If I was dividing by 4, 4 pi over 4. Dividing by 6, 6 pi over 6. This gives me 3 pi over 3. 2 pi says, well, you doubled it, so just double it, 6 pi over 3. Now, when I come all the way around, just like you did for the negative 300, you stop before you hit 360. I'm going to stop before I hit 6 because doesn't 5 pi over 3 come before 6 pi over 3? 1 up. And there I am right here. And it's still a 60-degree angle. It's once you get the hang of that, life gets easy. It does. But is everybody okay that I had the same values as that? Mm-hmm. But they were all positive because of my information box here. Said they're all positive in quadrant 1.
Why is your R2
R2, we said whatever triangle you want to put on. It didn't say you needed to have a unit circle. You could use your unit circle. So if you used your unit circle, then your x would say 1/2, right? And your y would say radical 3 over 2. And your answers would come out the very same. I specifically didn't use a unit circle because yesterday when you guys were giving me the triangles, you guys were giving me these instead of the unit circles. But you can put this on any one you want. You can put it on a radius of 4. They'll all reduce down. Okay, let's take another one here. Where am I? Oh, this is so off. Awful. Okay. 6 goes into 180 how many times? 30. So, oh, I have a 30, 60, 90. You really only have 2. But the 60 and the 30, sometimes one is the reference angle, one is not. But it's the same triangle. 1, radical 3, 2. Now, here's my circle. I'm starting here. Where is this negative forcing me to go? Clockwise. Good, the opposite direction. I'm only going 1 down. Right down here. So my reference angle, you told me, is 30. This is my negative pi over 6. So I'm going to put my measurements down. 1, 2, radical 3. Okay? Let me make my information box. X in this quadrant is positive or negative? Positive. Y in this quadrant is positive or negative? And R is positive or negative? Always positive. Good. Now, once I have my information box, I don't have to look back at this anymore. I don't have to check to see that I got the right positives and negatives because I know my x and my y values will give me my positives and negatives. So I will say the sine of this angle is y over r. Take my y over my r. The cosine of this angle is x over r. Take my x over r. The tangent of this angle is y over x. Negative 1 over radical 3. Okay? And my reciprocals, are you okay with just flipping them around? Okay, you're just going to flip them over. And don't leave me negative radical 3 over 1. Just make it be negative radical 3. It's not wrong, but you should make it negative radical 3. Like negative 2 over 1 should just be negative 2. So finding your angle to see what quadrant you belong to, finding out what special triangle this is, and then labeling it and using your axes to tell you where is your y positive, where is your x positive. Good? Okay? And one more. 3 pi over 2. So I know pi over 2. Pi over 2 is what? 90. This is pi over 2. So look, this is 2 pi over 2, isn't it? So what would one more set of 90s be? 3 pi over 2. Here I am at the 270. Now, I'm a quadrant angle. We call these quadrantal angles. We looked at one of them yesterday. I think we did the 90. Or we did the 0. On your unit circle, this is when a unit circle comes in very handy. On your unit circle, you move 1 over, 1 up, 1 over, 1 down. This is your XY point. Now, on your unit circle, what is the radius of this guy? 1. Okay, so it will still work with x over r, y over r, but since your radius is 1, the sign is the same as your y value then, isn't it? Because this is 1. What is your y value for this guy? -1. Your cosine is x over r, but your r again is 1. So your cosine is the same as your x. And what is your x value? 0. Your tangent is y over x. Now my y was -1. My x is 0. Can I divide by 0? No. This is undefined. And remember your tangent graph curves? Didn't they kind of got broken up? They stopped at different asymptotes. They couldn't hit a 90. They couldn't hit a 270 because they were undefined. Remember grabbing those tangent curves when we did those? This was your tangent graph. Your tangent went like this. Got cut off at the 90. Maybe that's not a good spot. Okay, got cut off at the 90 and did an asymptote. Got cut off at the 270, did an asymptote. They didn't make a continuous curve, and that's why. Because we can't divide by 0. And if you put that in your calculator, just say, put it in degrees and say the sine of 270. It will come out and give you -1. Cosine of 270, 0. Tangent of 270, I think it says can't divide by 0. It's an error, and I'm pretty sure it says divide by 0 ever.
Mine says domain.
Domain, yeah. It'll give you a domain error as well. Over 4. And let's just find sine, cosine, and tangent. How should I start? On the unit circle, well, we can use whatever you like to do.
Which triangle?
Okay, which triangle is this? So I look at 4. 4 goes into 180 how many times? 45. So right away I know I have a 45-degree triangle. So I come here and I just make myself the one that I remembered. 1, 1, radical 2. Each one of your special right triangles has one radical sign. Okay. Now, I can't take radical 1 because isn't radical 1, 1? So it's got to be the radical 2 in your 45. Okay? So now I got to locate this. I have 2 choices. If I want, I can multiply this and convert it to an angle. This goes in 45 times 5. I got to take out my calculator. 225. What quadrant would that fall in? Third. Okay? Or I can do it in radians. This is 0. This is pi. This is 2 pi. I need to make this with a denominator of 4. What number goes on the top? 4. I need it to cancel out, right? When I double it, what do I get? 8 pi over 4. So now, as I come around the circle, I'm going to count. I'm going to get to my 4 pi over 4, and what comes next? 5 pi over 4. I know this guy is 5 pi over 4. Ah, same as 225, isn't it? It's 180 degrees, and then 225. And what's 225 minus 180? 45 degrees. Isn't that my reference angle? So I'm okay. Now I know my triangle. They always open up to the x-axis. I wear a bow tie. So I label 1, 1, radical 2. So label it without any negatives. Now make this box. This is where your coordinate grid comes in real handy. In this quadrant, look at my x-axis. Is x positive or negative over here? Negative. X is negative 1. Is y positive or negative over here? Y is negative 1. And my radius? Always positive. So now I know, take the sine, y over r. Take the cosine, x over r. Take the tangent, y over x. Those I have to know. So I say sine, now remember, an easy way to remember this is cosine alphabetically before sine, x alphabetically before y. So cosine is the x, sine is the y. I just go right to this box. I say negative 1 over radical 2. X, negative 1 over radical 2. Negative 1 over negative 1 is 1. That's it. That's it. Some skeptical looks out there I'm getting. Okay? You guys try one. Let's pick another angle.
Is the next lesson about when you don't give us the ratio but the angle itself? To figure out?
It's kind of mixed. We kind of talk about what happens if this is not a special triangle. What happens if I give you like the sine of an angle that says the sine of an angle is 5 over 6. It's not one of your specials. So when you set this up, you're going to say y over r, and you're going to find the missing piece and give me all the functions that way. Sometimes we don't have special triangles there. So we do a little bit of that, we do a little bit more of this, we do some quadrant angles. We mix it up. So let's have you find 4 pi over 3 and find me the sine, cosine, and tangent. I don't care. All right, Azure, what quadrant does this guy sit in? 3? Okay. So how did you find it?
I tried doing it in radians, but it's uneven, so I don't know what I did wrong.
Okay, so what was your radian measured for pi?
3 pi.
3 pi over 3. Where does 4 fall? Before 3 or after 3? After. There you are, quadrant 3. So 3 goes into 180 how many times? 60. Now, if you have a hard time looking at it down here, start up here first. 60, 30, 90. Opposite the 30 is 1. Opposite the 60, radical 3. Radius 2. So now, opposite the 60 is 1. Opposite the 30 is radical 3. Opposite the 90 is 2. Now worry about your negatives. In the third quadrant, x is negative, and what else is negative? Wait, say this again? Oh, opposite the 60. Yes, thank you. I'm looking at this totally backwards, huh? And this is 1. Thank you. Opposite the 60, radical 3. So now, in quadrant 3, x is negative and y is negative. How about r? Positive. R is always positive. Okay? If you wanted to put your special triangle out of your unit circle triangle, absolutely that one works best too. So now, x here is a negative. Y is a negative. Now you can do your sign without even worrying about where you were. You don't even have to go back and say, all students take chemistry, all students take calculus. And your tangent. All I ask is that don't leave it to me like this. Reduce it. You should leave your fractions, your radicals, in simplest form. Okay? So, I don't have much to give you, so let me just give you a couple for homework. Why am I not getting a new page? Huh. All right.
Could have been misaligned.
It's probably not aligned, you're right. Let me try this. Nope, that won't give me a new page either. All right, so find me, I'm going to squeeze it right in here. All the values, let's just do three. Give me three values, sine, cosine, tangent, of 5 pi over 6, 4 pi over 3. Is that what we just did? Nope. Okay, 2 pi over 3. 7 pi over 4. And 4 pi. Find me all those values. That's the three regular values. For 3, wait, 5, this says 5 pi over 6. Sorry, that's hard to say. Pi. 5 pi over 6, 2 pi over 3, 7 pi over 4, pi. Okay? Find me those values. Must be like frozen on the board here. Oddly.